and welcome to my lecture series on bioinformatics. Now, to get started with our series, we're going to start off with probability as it's one of the most fundamental topics in mathematics as well as statistics. So for today, the main core ideas that we're going to try and cover include the addition rule, the multiplication rule, and the difference between dependent and independent events. So let's start from the beginning. Probability basically measures how likely something is going to occur. Now, the formula for probability is given as the number of favorable outcomes divided by the total number of possible outcomes. So let's just say you have a dice and you're trying to figure out what is the probability of me being able to pick a 4 each time I roll that. So the probability of picking a 4 is going to be 1 divided by all your possible outcomes, because dice has 6 possible outcomes, and that's going to give you 0.167. One important rule to remember about probability is that it's always going to lie within the probability scale, which ranges from 0 to 1. And 0 means that it's very impossible for an event to occur, and 0.5 is a 50% chance of something occurring, and then 1 means you're definitely certain that something is going to occur. Now, before we move on to applying or discussing the addition rule, we need to discuss Venn diagrams and the union and the intersection rules. Now, on the left side, we see that there is a union which is annotated or written as A union B, and O is the word to remember what is the probability of A or B occurring. And in this union, basically what we're going to do is we would be sort of like uniting the outcomes that you're getting from A together with the outcomes you're getting from B. So for instance, let's just say on A you had different experiments that you did, or different rolls of the dice, and then the numbers that you picked were 1, 2, 3. And then on B, you also had different experiments that you did, and then the numbers that you ended up rolling were, let's just give an example of 2, 3, and 4. So now when you say A union B, you're basically going to get your probability of A of picking all the numbers that we discussed in A, and then the probability of picking all the numbers that we discussed in B, minus the union or the numbers that are going to be occurring in this bracket. So then we move on to discussing the concept of intersection, which is on the right. So basically with intersection, the main thing to remember is and. We're saying that the events that are occurring in A and B, what is common in both of them, and the intersection is basically the overlap. So the reason why it's important is that when you're trying to calculate, or within the addition rule, when you're trying to figure out what is the probability of A or B occurring, we always add probability of A and probability of B. But in doing so, we're also including the overlapping regions, especially for when you have things that are dependent. So we don't want to count those twice. So that's why there's a need to always subtract this intersection. But in the event that you have independent variables, you don't really need to worry about. So the concepts of dependent and independent variables, we're also going to discuss that. And sometimes there's a concept of the events being mutually exclusive, meaning that these events cannot happen at the same time. An example of that would be you cannot have a sunny day and a snowy day at the same time. So those two events are mutually exclusive. So we're going to move on to discussing the addition rule. And then in this example, the formula for the addition rule is going to be the probability of A or B occurring, which is found as probability of A plus probability of B minus the probability of A and B, which is basically the intersection, which is basically what I've been showing in the previous Venn diagram. And then this minus A intersection B is mainly used when you have events that are dependent that are not mutually exclusive. So the example that we're going to be using is we're going to be using 10 balls. We have 3 that are red, 2 that are blue, 1 that's green, and 4 that's gold, making a total of 10 balls. So now the probability of getting a red ball is going to be 3 over 10, or 0.3, and then the probability of getting a gold ball is going to be 4 over 10, or 0.4, and then probability of picking a red or gold ball is you're going to add your probabilities of red, the 3 over 10, plus the 4 over 10, and that is going to give you a 0.7. Now notice that the red and the goal cannot occur in a single draw because they are mutually exclusive. So when events are mutually exclusive, that means there's literally no overlap, so there's no need to subtract the overlap, like A and B overlapping. So we're also going to continue in the second example where we're trying to pick the probability of red or blue, and that's going to be 3/10 plus 2/10, which is going to give you 5/10, and that's going to give you an outcome of 0.5 as the probability. So now we're going to move on to the multiplication rule. Now what the multiplication rule answers or tries to answer is what is the probability of event A and B occurring for independent events. So now we're going to go back to dice, and then we're trying to figure out, okay, what is the probability of, when I roll the dice, what's the probability of me picking a 3? That's going to be 1/6. And then what's the probability of me picking or rolling a 5? That's going to be your 1/6. So to get the probability of picking a 3 and a 5, we multiply 1/6 by 1/6, and that'll give you 1/36, and that's approximately close to 0.03%. And then that means from the 36 possible outcomes or combinations, you can only be able to pick the chance of rolling a 3 and a 5 is going to be like 1 in 36. So we're going to move on to discussing independent events in greater detail. So for independent events, it means that the outcome in event 1 does not affect the other. So when you roll a 2, getting a 2 on the first roll doesn't change, and it doesn't affect your second roll. So the second roll you could roll a 6, and to be able to calculate those probability is going to be the same formula that we had discussed before in the multiplication event that we discussed before. So it's going to be the probability of getting A times the probability of getting B, and in this case it's going to be 2 and 6, and it's going to be 1/6 times 1/6, and it's going to give you again 1/36. And these probabilities can be done or when you're calculating a coin flip, or when you're rolling 2 dice, or when you're picking a card with replacement. For cards, when you start to not replace it, then that becomes a dependent variable. So we're going to move on to the next part, which is discussing dependent variables. So for dependent variable, basically what we're saying is that the first event will affect the probability of the second event. So what we mean by that is we're going to take another ball which has 5 balls, 3 of them are red, and then 2 of them are going to be blue. So then the probability of picking the red ball, picking a red ball, is going to be 3/5, and that's going to be 0.6. And then in the next part, so we're going to pick this red ball, and we're not going to replace it. And then we're going to try and pick what is the probability of picking the red balls. Again, it's going to be 2/4, because now we have removed the other ball, and we now only have 4 possible outcomes. So it's going to be 2/4, and it's just going to give you a 50-50% chance. So now what we're going to have is that the annotation is going to be the probability of picking a second red ball, given that you've picked a red ball. That's going to give you the 2/4. So the key part to remember is that the probability of B given A means that the probability of B given A has already happened. So the pool has changed. So that's what we mean when we discuss dependent events. So the dependent events are dependent on something happening. At least that's how I understand it. I hope this at least gives you a short and a small introduction to probability. And just to remember that in the addition rule, the key term to remember is the OR, and this is the formula for the addition. And then the multiplication rule is the key to remember is the and what, like, it's the intersection. And then for independent events, they're not affected. The first outcome doesn't change the probability of the second one, and then for dependent events, the first outcome does change the probability of the second one. Thank you very much for your attention. Feel free to comment or suggest any other videos.